Hello friends, in today's tutorial, let us clear the concept of induced EMF and induced current. To make you understand induced EMF and induced current, for that I am taking the help of this experiment. In this experiment, I got a coil, I got a galvanometer, and I got a coil here, and I got a bar magnet. Now what I'm going to do, I'm going to move the magnet from top to bottom. Let us see what happens if magnet is moving from top to bottom. If I thrust or if I make the motion of the magnet inside the coil from top to bottom, then as the magnet moves from top to bottom, we see the deflection in the galvanometer. Let us see the once again. Now I start moving the magnet from top to bottom. We see the deflection in the galvanometer. Now let us move the magnet from bottom to top. Earlier we moved the magnet from top to bottom. Now in the second case, I am moving the magnet from bottom to top. What happens in case of deflection? Now let us start moving magnet from bottom to top. When we are making motion of the magnet from bottom to top, the direction of deflection in the galvanometer is also reversing. Let us see the experiment once again. As the magnet is moving from bottom to top, galvanometer deflecting in reverse direction. Summary is, we got a magnet and we got a coil, and magnet is moving inside the coil. When the magnet is moving inside the coil, then galvanometer showing deflection. When the magnet is moving from top to bottom, then deflection seen in one direction. When it is moving from bottom to top, then the direction of deflection is also reversing. Now suppose we make the motion of the magnet very fast from top to bottom and bottom to top. In both cases, the galvanometer will show the deflection. But when you move from top to bottom, the deflection in the forward direction, and from bottom to top, the deflection would be in the reverse direction. Here, I wish to clear one thing, that galvanometer show reading only when it is connected across a cell or a battery. Unless and until a galvanometer connected to some voltage source, it will not show the reading. In this circuit, no voltage source is present. Only the magnet is moving to and fro inside the given coil. Then also the galvanometer showing the reading. So there must have some voltage developed in the coil when the magnet is moving to and fro motion. Technically, the voltage which is produced in the coil is called electromotive force. Electromotive force is one which pushes the electric current in a particular direction. Because there are the two parameters when you talk about electricity. One is the voltage, another is the current. The energy which is responsible to push the current or electrons in a particular direction, nothing but called electromotive force. When we are making the motion of the magnet to and fro motion, then the EMF is produced in the coil. This experiment was done by Faraday. Now suppose we keep the magnet outside the coil and move from one position to another position. Suppose we bring the bar magnet towards the coil. Then also deflection is seen in the galvanometer. And if the magnet is taken away from the coil, that is moving away from the coil, then the deflection in the galvanometer also shown reversed. Now if the magnet is moved quite fast outside the coil, then we observe that the galvanometer showing deflection in both forward and reverse directions. From above two experiments, it is clear that irrespective of whether the magnet is inside the coil or outside the coil, but if the magnet is in motion, then the deflection is observed in the galvanometer. Now suppose we keep the magnet at rest anywhere near the coil, either close to the coil or away from the coil or inside the coil, but if the magnet is kept at rest, that means magnet is not allowed to move, then no deflection are observed in the galvanometer. That means the deflections are observed only when the magnet is moving. As long as the magnet is under motion, the deflections are seen in the galvanometer. You see that when you go a dance party and you are dancing, you can dance only when there is a music. If there is no music, you cannot dance. That means if you are dancing, it is understood that the music is already playing. Similarly, the galvanometer do not show deflection unless and until connected to a voltage source. In this experiment, there is no voltage source. The only logic is that the magnet is moving inside the coil or outside the coil. That means all secret is in the motion of the magnet and the coil. So according to the Faraday, whenever a magnet is moving near to the coil, inside the coil or outside the coil, but it is moving near to the coil, it is moving with respect to the coil, then the EMF is always produced in the coil. The EMF produced due to the motion of the magnet is called induced EMF. And whenever there is a EMF, the current is always behind it. So whenever the EMF is produced, the current is also produced in the coil. This current is called induced current. Thus, when magnet is moving to and fro motion inside the coil, the two things are happening. One is induced EMF is developed, and because of the induced EMF, the induced current is produced in the coil. When the magnet is moving to and fro motion with respect to coil, the flux linked with the coil changes. And due to changes in the flux linkages with the coil, two things are happening. One is the development of production of induced EMF, and because of the induced EMF, a current start flowing in the circuit. The current which is start flowing due to induced EMF is called as induced current. In a circuit, current flow is possible only if there is a potential difference. That means due to the to and fro motion of the magnet, a potential difference is created. That means the induced EMF creating a potential difference in the circuit, and because of this potential difference, a current produced in the circuit, that is nothing but induced current. Definition of induced EMF. Whenever the magnetic flux linked with the coil changes, an EMF is automatically developed in the coil called as induced EMF. Definition of induced current. And because of induced EMF, a potential difference is developed in the coil that is responsible for creating a current flow in the circuit. The current due to induced EMF is called as induced current.